We're at Earth X. We're going to talk to our next guest, Peter Fiekowsky, the founder of the Climate Restoration Program. Peter, I'm so happy that this is the last conversation of the day for me, and I guess maybe for you, because we're going to talk about probably the most important thing. That's restoration. People talk about sustainability, and that always has that in it, like, okay, let's do more with less, and then hopefully we get somewhere. But that's not as inspiring and mind-blowing, changing the world kind of thing as restoring. So you tell me, I read a bit about your work, that all that CO2, that is the problem, and that's somewhere in the atmosphere, that we can, I'm going to say, easily bring that down. But probably easily is, I should emphasize that may be a little tricky, but tell me why you think this can be done.
Yeah, well, the why is fairly simple. Most of us know about the ice ages that happen periodically for millions of years. And before an ice age, nature removes 1,000 gigatons of CO2, and that's what cools a planet and has the ice form. And over the last few decades, science has figured out, how does nature do it? When I was an undergraduate in 1975, 50 years ago, we didn't know hardly anything about ice ages, much less how they work. But we do now. And now that we understand that the way nature removes that CO2 is with photosynthesis in the ocean. Now, we talk about photosynthesis on land with trees, but we all know that trees die after a few decades, and they rot, and the carbon goes back in the air. Mm-hmm. So it's a nice thing. We like trees, but that doesn't remove massive CO2. In the ocean, when plants die and the animals that eat them die, they sink. And there's almost no oxygen in the deep ocean. They don't rot. And so it disintegrates and turns into carbonate, dissolved carbon. And so we know it's possible. The groups I'm working with have modeled it out and said, well, if we were to do it, how would we do it? And it comes out to probably $1 billion a year. Now my advisors say, call it 10 billion, because we don't know. And even $10 billion a year for the whole planet is pretty close to zero, given the...
Yeah, no, that's nothing. But
yeah.
So let's go immediately into what you're going to do then. So you're going to plant seaweed in the oceans, is that it? Or what do you do with that billion?
Yeah, so it's replicating how nature does it before ice ages. And then there's an interesting effect that happened in 1992. If you look at the carbon, the CO2 level, they call it the Keeling curve. It was going up for decades since they started recording it in 1958. In 1992, it was flat for 16 months. And then it went back up again. And so one would ask, and more of us are asking, well, wait a minute, how did that happen? Mm-hmm. And it looks like what happened is after the Mount Pinatubo eruption in 1991, there was enough nutrients in the ocean around there to get the phytoplankton, the plankton, the algae and plants growing. And it's the only eruption in the last 50 years, which happened where the ash fell into a downwelling eddy. And so the trick appears to be that if you throw the ash, which is rock dust with nutrients, over a downwelling eddy, the downwelling eddy will pull it down so that it gets into the deep ocean before the fish eat it. In most places, when you get when the ocean is green, you have all the fish in the world, and they eat it, and you're carbon neutral. Mm. And
so you need to get it beyond the fish, if you like.
Exactly, and that's why the downwelling eddy seems to be critical.
And now, there are a few of those around the world.
There are a lot. Yeah, there are hundreds.
Yeah, of course. Yeah.
And that's what our plan is. Now, we have a lot of evidence that it will work, but we haven't actually done it yet. We're working to raise a few $1 million this year. And so if anyone listening wants to contribute, that would be fantastic.
That makes sense, yes. So you would just do, how would you be able to measure that? So you take one of those spots, one of those eddies, and you put in the...
I love that question. So I'm a physicist by training, an astrophysicist.
Yeah.
I love measuring.
Yeah.
It turns out that when we look at what happens after volcanoes, the Pinatubo eruption, the Tonga eruption 3 years ago, and then there was a 2018 eruption in Hawaii, using the NASA orbiting carbon observatory. It measures carbon from orbit.
Yeah.
We can actually measure the CO2 removed when those eruptions provided the nutrients which turned the ocean green.
Yeah.
Just for a while. After a little while, it stabilized, unless it was over a downwelling eddy. And so we can measure it by the satellite,
And you see the increase of plants, basically.
Well, you can see the plants, but as I said, the plants don't tell the whole story, because animals will eat the plants, digest it,
Yes.
and metabolize it, and it comes back out as CO2.
Okay.
And so we actually measure the CO2 level. And so with the satellite, but primarily...
The CO2 level above the surface then?
Yeah. Yeah.
And that should be lower there, that is your proof?
Yeah. And there have been 13 studies of this ocean fertilization over the last 25 years. And when they've measured it, they measure typically, let me do the calculation here, about 50 parts per million, so about a 15% reduction in CO2 at the ocean surface. Easy to measure.
So the measuring part I understand, but what else is this to do with physics or astrophysics?
Well, the interesting...
I mean, the eddies go down, I get that part.
Eddies go down, yeah.
That's gravity, but this is not physics, is it?
Yes and no. It's not, really. The difference is that I came into the field new about 10 years ago, because I'd made a commitment to my family and friends that my mission in life is to leave a world that we're proud of to our children. And about 10 years ago, my daughter came back, or 15 years by now, came back from college.
Yeah.
And I said, no, wait a minute. If we continue increasing CO2 levels, I will not be proud of that.
No.
And I had figured, as I said, in 1975, that EPA or someone would do it. And after 35 years, there was nothing happening.
Yeah, we need to go back there. So you are in college at MIT, not the last place on the planet to learn something, right?
Yes.
And you're there, and you're looking for your niche, if you like.
That's right.
And so you got to, you saw that the beginning of the environmental movement was there. Yeah. But you concluded that you didn't have much to contribute there because you thought others were doing that?
That's exactly right. When I first read about global warming.
Yeah. And this is in the 70s?
Yeah, in the mid-70s. Yeah. And I was just devastated. Now, I knew it was happening. Right? We're not that different in age. No. And with all the big cars, and we knew it was happening, but we didn't think about it. But then the article said, you know what? CO2 is going up. By the first or second decade of the 2000s, it's going to be devastating. I said, I'm going to be alive then. I'm going to be in my 50s.
Yeah.
And it's like, shit, pardon my French.
Yeah.
And and I figured, I'm a physicist. We don't do chemistry.
No.
And so I continued my astrophysics work, but and figured that someone smarter than me would figure out how to get the CO2 out at the correct rate.
Yeah.
And
so you were actually planning to sort of, start a civilization on Mars, because that was what you're thinking, right?
No,
not.
No. I just wanted to have a nice, peaceful existence. I was studying chemistry in a distant galaxy after a supernova.
Ah, all right. Okay. Well, that's good.
No one got hurt. I figured no one would get hurt.
Good for you. But anyway, you concluded later on that what you thought had to be done in the 70s still hadn't been done, whatever, 10 years ago.
That's right.
And now you're doing it.
Now we're doing it. Yeah. And so the physics comes in because in my astrophysics background, dealing with things that are huge exponents, billions and trillions of miles, of meters, of kilograms, that's easy for me, because when I was young and before calculators, I just did those things. Yeah. Well, that's not normal for an oceanographer. So when an oceanographer says, well, how much CO2 is absorbed when the ocean cools by a degree? They don't have a way to calculate it. For me, it's like, oh, I can calculate that. Give me 10 minutes. I'll get right back to you.
Yeah.
And the answer is, in 1991, when the eruption happened, our planet cooled by 0.5 degree Celsius, and that absorbed about 2 to 10 megatons of CO2. That's it.
Okay. Yeah, and it took you 10 minutes.
Yeah.
Yeah, okay. So this is an obvious solution. It's not geoengineering. It's playing with nature or stimulating nature to resolve the issue. It costs $1 billion a year.
Yeah.
It's nothing. So everybody should be waiting for you.
Yeah, and the speed is picking up. Here at EarthX, people are talking about it more and more. This is my 3rd or 4th year here.
Yeah.
And it's very exciting. It means that you have to, the politics is the tricky part, and I haven't nailed it yet. The politics, it's not the politics of Washington right now, which is crazy. It's the politics of the UN formed their thinking on climate in 1980, when Reagan put took the solar panels off the White House. It became a political thing, so the UN started talking about it. They said, let's just stabilize CO2 levels. And in 1980, that would have been fine. In 1980, we couldn't see global warming. It was a theory. Yeah. But no one has changed the rules since then.
No.
And so the UN goal is still just to stabilize it, even though it's intolerably high already. And so we have to figure out, how do we get enough people to talk about bringing it back to safe levels from when you and I were kids.
But you say it's $1 billion a year.
Yeah.
Now, how many years do we need to do this?
The plan we have, now we call it civil engineering.
Okay.
Because we're engineering the world that people live on.
Yeah.
And by 2030, in just 5 years, we have a plan to scale up what we've learned from 1992 after Mount Pinatubo. Yeah. And our goal is by 2030, we should be able to have CO2 falling.
So, but how many years do we need to do it before we are
20.
20? So it's a $20 billion project.
Yeah. 25.
Okay, 25. Fine. 25 billion.
Yeah.
Give and take. Make it 50 billion. There is a billionaire here who's sitting on that money.
Yeah. Yeah.
Should be simple. I mean, this is ridiculous, isn't it? That we are talking about such a major solution, which requires really no money, for somebody who's sitting on money, doesn't know what to do with it. I mean,
yeah. So here's the barrier that we have to get over there. Part of it is the United Nations. Yeah. That we're all good world citizens and really don't want to stick our thumb in the eye of the UN. No. Because their 50-year-old goal is out of date. But then the flip side of that is the scientific community it says, listen, this isn't in the UN framework, and it's never been done before by humans. No. And so when billionaires ask advice from the scientists say, this is a little radical, it could be bad for your reputation. Yeah. But the only and this is why you and I are talking.
I get it, but you and I know that a billionaire like the one who's now willing to do all the crazy things in the world, he wouldn't need that kind of scientific advice. He would do it if he would believe it himself.
Yeah, so, and I've heard that in past decades he had funded.
Of course. Yeah. But now he's doing other things. But somebody like that who doesn't need the whole United Nations to confirm the idea, because that's never how change in the world happens, of course.
Yeah.
Wow. What is your next move?
Next move is we're looking for a few $1 million funding to get a test done. Nominally, we want to do it near the Pinatubo eruption in the Philippines. The bad news is that that's a bit of a war zone with China. Now, the Philippine Coast Guard says, if we actually did a peaceful project here, that could avert the war. That could be a good thing. But then a lot of the scientists say, well, we're not sure if it'll work there. And I'm thinking, well, it worked there in '92. Yeah. But the level of iron and nutrients in that area, they're not terribly low. They're low, but not terribly low. And so we can also do that pilot test off of California. And so we're right now this month formulating how we might do that and make it a little bit more normal.
Yeah.
But it depends on who we get interested in, how bold they are.
Yeah.
And how much of a hurry they think they're in.
Yes.
Because
let me ask you, how much of a hurry are you in?
Well, we can definitely do it by 2050. And if someone is in a hurry and says, I think we should try to do it by 2040, that's actually also probably viable, but we're not going to,
Hey, and is there a risk that we, unwillingly we cause an ice age?
No, because when the nutrients are added, it's mostly iron in insanely small amounts. It's about, if you imagine a square meter of ocean, it takes about the size of 1 grain of salt, that much iron sulfide or iron oxide. This is insanely small amounts.
Really
that's why the cost is so low. And nature does it with dust storms. So the dust storms blowing from Sahara.
And the iron is such a change in the nutrition.
Yeah.
That everything starts growing.
Yeah, yeah. And so it's extremely inexpensive.
Okay, so I need
and after you stop doing it, the iron sinks
and then it's over.
And it's over. So
and there is no, there's of course all the time, whatever we do, there is some of these unintended consequences.
Yes.
So what could be wrong, could go wrong here?
Well, not very much, because nature does this over and over and over again. So we know anything that could happen has happened, and nature has adapted to it over millions of years. The interesting thing is, the only moderate scale test that was done was controversial in 2012. They produced, it was up in Alaska, off of Alaska, and the pink salmon population skyrocketed. It was like 5 times more than was expected, presumably because the fish had a lot of food.
Yeah.
Because the phytoplankton is food, the base of the food web, and at that time in July, the young salmon were very susceptible because they haven't eaten much, and there was this feast. And so the main thing is the fish populations can explode, can recover. And then the whale populations.
But that would be an
recover.
Intended consequence, or at
beneficial.
least it would be a beneficial consequence.
Yes, yeah, and those are the only. They did not expect that much of a increase. They did not expect the orca whales. There hadn't been any orca whale births in that area for, I'm told, 7 years, and then there were 3 a year and a half later, because they take a long time to get born, to develop.
So I understand that you need money. That makes sense. What else do you need?
Well, we need people talking about it. That's the main thing. So my advice to people is, everything you do, if you're inspired by giving our children a safe climate like we were given, just call it climate restoration. So if you're gardening, saying, this is my climate restoration project. If you're cleaning up the plastic and recycling it, so, I'm recycling for restoring a safe climate. Once people are thinking about that, it'll be natural for the billionaires to fund it.
So when you sit down with your daughter these days, what do you tell her?
I tell her we're getting there. She says, Dad, you keep working on it. She's working in a nonprofit on developing offshore wind. And so she's working on her side of it.
Are there grandchildren?
I have 5 grandchildren.
And what do you tell them?
Well, the oldest is 4, so I don't talk to them about it very much. But when they get older, the way I work is I just tell people, we are going to restore the climate. I'm not going to my grave without having done it.
Thank you, Peter.